Hello, everyone. I'm Dr. Wang. Here is the question. We want to prove this trig identity. In general, how to prove a trig identity? We usually pick one side to start to simplify. This side looks more complicated than the other side. For example, we start from left-hand side to simplify it until somewhere, maybe here, to reach the right-hand side. This means we have done the proof. Similarly, we can start from the right-hand side to simplify until we find the answer which is the same as the left-hand side. Sometimes you don't get this. You have to simplify the left-hand side, stop somewhere, then start to simplify the right-hand side until you have the same answer as the left-hand side. How to simplify? Usually, if we have the fundamental trig identity we can use, we use those identities first to help us to simplify. If we don't have identities to use, what we can do is to convert all trig functions in terms of sine and cosine. Put all those trig functions in the same sine and cosine common ground to simplify. Look at this example. We start from the left-hand side. We rewrite the left-hand side trig functions in terms of sine and cosine. By definition, secant equals 1 over cosine. Tangent equals sine over cosine. Secant equals 1 over cosine minus tangent. Tangent equals sine over cosine. The numerator, the denominator, they have the same common denominator, cosine alpha. Cosine alpha can be canceled. Then we have 1 plus sine alpha over 1 minus sine alpha. From here, looks like we cannot go any further. We stopped here, and to start to simplify the right-hand side. The right-hand side is this. The numerator is a complete square. It is 1 plus sine alpha, then square. Denominator is cosine alpha square. The numerator only has sine. Can we convert cosine into sine? Yes, there's a basic identity. Sine squared plus cosine squared equals 1. This implies cosine squared equals 1 minus sine squared. Why are we doing this? We want to cancel some common factors from both numerator and the denominator. 1 minus sine alpha squared, we can consider 1 as 1 squared. 1 squared minus sine squared, which is 1 plus sine times 1 minus sine. Now we can see the numerator and the denominator have the same common factor, 1 plus sine alpha. We can cancel 1 from the numerator. You have 1 left. And the denominator, this one was canceled. 1 minus sine alpha is here. This is what we have from the right-hand side. It is the same as what we simplify the left-hand side. Left-hand side, we have this simplest form. This is also the simple form of the right-hand side. This is a bridge. That means we have proved the left-hand side equals the right-hand side. That's all for today. Thanks for watching and see you next time.